Okay, hello guys. Today we are talking about the area of a sector. Okay, so let's move to the first part of the area formula. So as area, we can just consider like here is a circle and here is a sector of this. Okay, and then we can set for the sector that the angle here is theta, and we can using the theta over total angle is 360 degree, then times the circle's area that is pi r squared. Okay, so that is for the area right here. So you can also just written down 360 degree as 2 pi. So that is theta over 2 pi times the pi r squared. So now we can find that pi can be divided by each other, right? So that is a half times theta times r squared. Okay. So last lesson we already said like r theta equals to the arc length. So here is arc length, right? R theta. So here is radius, and we can say that the area here equals to a half times r theta times the r. Okay, okay. So also you can just consider it as a triangle. So you can find the value, the shape of it is very similar to triangle, right? So triangle's formula is the height times the base times the half, right? So here's also the half times the base theta r times the height is radius. Okay, that is a half times theta r squared. Okay, so the same formula as before. That is for the area formula. And also, like for example, there's an example for you. Like find the area of a sector with radius 4 meter and angle 3 pi over 4. So you can draw the graph. Here is for radius 4 meter, and the angle here is 3 pi over 4. So you can just written down as like a half times radius squared times theta. Okay, so that is a half times 4 squared times the theta is 3 pi over 4. Then you can calculate as 6 pi meter squared. That is a final answer. Or you can also use the calculator to calculate 6 times 3.14 as our final answer, okay? So here, also we have already learned about in the IGCSE that the areas of the triangle, right? So because the triangle's area can be considered, here is ABC angle, here is side A, side B, side C, right? So it means a half times angle side C and then times AB, right? So it's 2 adjacent side and then times the angle between them, okay? So that is for half times radius squared times sine theta. So if here we have a sector, and here we are just drawing a triangle as A, B, C. So we can set here theta R, R, and the triangle's area ABC is a half times R squared sine theta, right? And for the sector's area, it's for a half times radius squared times theta, right? So you can just using the sector's area minus the triangle's area, right? So that is a half times radius squared times theta minus sine c, okay? That is for our final answer of it, okay? That is a visualization for the segment, so you can find here. That is the area we want to know, okay? So just like in a working sample here, like I said, here is an area of a segment formed by a chord in the circle and the radius 10 centimeter, right? And the center is pi over 3. So if you want to find this area, just you can using your rules like a half times radius squared times the theta. That is for the sector's total area, right? So we can say here the sector's area is a half times 10 squared times the pi over 3, right? But that is for 50 pi over 3, right? Because 10 squared equals to 100. 100 over 2 is 50, right? 50 pi over 3. And then the triangle's area can be written down as area equals to a half times the radius squared then times sine theta, right? So that is a half times 10 squared times sine pi over 3. So this value, because sine pi over 3 equals to square root 3 over 2, so it can be written down as 25 times square root 3. So then you can just using the sector's area minus a triangle's area equals to the segment area, that is 50 pi over 3 minus 25 square root 3, that is for 9.06 centimeter squared as our final answer, okay? That is for this problem. And here there are still two exercises for you to solve it. You can just pause the video and try to do yourself. But if you want to follow with me, you can keep on going, okay? So let's move to the first problem. Find the area of a sector with arc length 12 centimeter and the radius 10 centimeter, right? So just you can draw the graph like here, that the arc length is 12 and the radius 10, right? So you can calculate in the area that is a half times the base times the height, right? So also you can just using a half times radius square times theta. And here we knew that a half times radius and r theta equals to the arc length, right? So here equals to half times 10 times the 12, right? Because the arc length here equals to 12 centimeter. So the final value equals to 60 centimeter square. This is our first question, okay? And for second question is that calculate the area of shaded segment if r equals to 5 centimeter and theta equals to 1.2 rad. So also you can just draw the graph like here that this is 5 centimeter and here theta equals to 1.2 rad. And just you can using the formula like the sector's area is for a half times theta times r squared, right? A half times 1.2 times 5 squared. So that value here is for 0.6 and it is for 15, right? And for the triangle's area, you can just using a half times r squared times sine theta, right? That is for area of a triangle. Okay, so you can just using a half times 5 squared times sine. Here, please remember that is 1.2. So you have to translate into degree. Okay, so that is for 1.2 times 180 degree over pi, right? So just using calculator to calculate this value and then using your sector's area minus the triangle's area right here. So you can find your final answer of the segment area. Okay. So that's for this lesson. Hope you can truly understand for the area of a sector and area of the segment. They are very important for you. Okay. So that's for today's our lesson. See you next time. Bye.